Hey, welcome back. In the last video, we had discussed about I think the sort is subaric problem, and let's move forward from that. Let's do next one. Degree of 704 binary search. Most probably this is going to be the easier one. Let's okay. Okay, and let's do 704 binary search. Given an array of integer nums which is sorted in ascending order and an integer target, write a function to search target in num. If target exists, return the index, otherwise negative of 1. Okay, so one thing I know from my experience that whenever something could have been worse, but it is better, but what you are given is something better than that. Okay, for example, nums could have been given something like let's say let me do something like comma something means like not in order, anything could have been. Okay, so this prob problem would have been entirely different, but in our scenario the nums is ordered. Okay, and if something is ordered, uh, the solution becomes like very concise. Okay, um, in my experience, let's see how it goes. Given an array of integer nums, okay, so again, so in the question written, it is written itself that it is a binary search, but again, in a real life that would not be the scenario. In the real life, let me try to explain. Let's say 1 2 3 something. I misplaced it. Okay, so this is given in order. Question says that you have to find a target. Let's say the target is 5. This is what I have to find out, and then I need to search it. Okay, what's the index of it? Okay, in real life, what does it mean? Let's say you are standing in a school queue, means like in the morning prayer, and then again, the peoples are like arranged or like sorted in any given line of a class. The students are like mostly sorted in a ascending order, means like of their height. Okay, now you were to ask like where where a person with a specific height stands. Okay, you need to know the location of that. That's something you're looking for. Let's say a person who is like 5 foot tall, and you need to know where he is located at. Okay, that's something the question is. And if we try to do it in the in your most natural approach, what you will do, let's say you are standing over here, you will go and keep on checking them one by one and one by one till the time you are able to find where that person is. Okay, And you might think like, yeah, this is the, I think, the most optimal way, uh, I know, to find it. Okay, so in this scenario, after just the five comparison, you would have find the person. Okay, but what if there is a faster way? Okay, so in this scenario, let's take seven is something which I need to search. So for this given data set, how many comparison will I need to make? Seven comparison, no? And that is something seems good, but if the number of students are more and you have to go to the very end, till the very end of the queue, that can be very problematic. So let's see. The other approach is, you, regardless, like you go to the middle of the queue, and then you find, okay, so this requires this to be sorted. Again, the height needs to be sorted. Then you go to the center, you find like, if the if the height I'm looking for is the current person, is that, if not, should I go to the left or should I go to the right? Okay, no, I should go to the right. Then again the center somewhere, and then should I go to the left and right? Right. Again in the center, should I go to the left, to the right? Yeah. So by doing some of this approach, we would be able to. What's the problematic part? Not the problematic part, but from the compre let's say from the understanding point of view, what comes challenging in this question, there is some sense of even and odd. Okay, at least in my understanding. Let me try to show you what does it mean. Okay, for example, let's say uh, I have a list and in which I have some numbers. Let me do it so I know. I'm intentionally keeping it same as index 4, 5, 6, 7, 8. Okay, and then if I do something, let's say print length of L divided by 2, what do you think? It's an even, sorry, it's an odd first, like there are 9 elements. If I do 9 divided by 2, what do you think will come out? Will it be 4.5 or 4? Let's say 4.5. So if you do something like this, then what comes? 4. So the floor would be chosen. So this is something that you need to do. Let's say if the number of element were, okay, wait. Let me also show you this. Okay. So what's the middle element? 0, 1, 2, 3, 4. You know, like this is correct for the 9 element. 4 to the right, 4 to the left, and then center is 1. Okay. Now, if these were even, then the decision comes slightly trickier, and in that condition also, this becomes the center, and the left becomes this, and right becomes this. So there is some sense of like uh, uh, slight not center is not always present. So that's the main point. Okay, let's do. So while I start with I equal to 0, and then while nums of I is not equal to target, while nums of I is not equal to target, Then if nums of I is less than target, do something. If nums of I is greater than target, do something. Okay, what I need to do, okay, I need to know the left and right first. Left equal to 0, right equal to length of nums. Okay, if number is less than target, left is equal to I, should it be I or center? Okay, let's do something. Center is equal to L plus R divided by 2 C. If C is not equal to target, then C plus 1, R will remain the same. And then if this right is equal to C, if number is greater than the target, which means if the number I'm looking for, let's say target is this, and this number is coming out to be, let's say target is 4, and I'm here. If target is greater than the number, what is number? Number is this. What's the target? Target is this. Sometimes I becomes zoned out again. This is the target. Is it greater than the number? No. Oh man, let me comprehend it. I don't know. I'm zoning out probably. If number is greater than the target, if the current number where I'm standing is greater than the target, then I need to go to the left, no? Okay, then right becomes C minus 1. Okay, left is done, right is done. While then how to break out of the condition, man? While center is not equal to target, return C. Let's see. Oh, this will not continue, I guess. Okay, so this is something which I need to calculate in the loop, no? Yeah. Okay, while okay, I can start with okay, but I start with this. Yes, correct now. It's, okay, well, when left and right is not equal to same, that would be the condition, I guess. When L is not equal to R. Okay. Now I need to break if the number is not there. Okay, probably I'm not getting. Let's see. Let's see. Probably this is some bit of not a good day for me, but let's see how to. What's wrong? I'm doing. The issue with your code is that you are calculating the middle point incorrectly in the binary search, especially the condition for updating the source boundaries is causing an infinite loop or incorrect behavior. Left and right. In typical binary search, the left and right boundary are usually set to that is correct. In your code, you are setting length. What? That's correct, no? L equal to 0. Yeah. In your code. Okay, am I? Oh, sorry. That's that I knew, but somehow I missed. But let's see. The loop condition, the loop can cause the problem, especially n equal to r supposed to be eventually coverage. A better way to handle the termination condition in a binary search is to use the while L is less than equal to R, which ensures that search spaces are valid and L can equal R when target is found. Your index calculation C equal to L plus R is correct. However, the way you are updating needs some minor fix. When you update R or L, you should make sure that you are adjusting them to the narrow search space correctly. Let's see how. Continue where the left is less or equal to the right. C equal to this. If C, okay, so that's the approach. Return -1 if I reach here. If number at C is equal to target, that means return the C itself, and this should be here. Let's see how it goes. Where was it? If nums of C is equal to target, if if nums of C is less than target, else what? Oh, the left half, right half. That should be correct. Yeah, both are coming out to be correct, but why this? Why not this? This. The reason it does not work in this case is because of how binary search narrows down the search space. Access block while L is not equal to R can cause the problem in typical binary search. the loop should continue as long as there are valid terms, so you can need to be careful. What? When such space is just an element. What if I have only one element? You want to check if the element is target, but L is not equal to R, will not let it happen. What? No. Consider this condition 1, 2, 3, 4, 5, when is initially L is equal to 0, R equal to 4, and which holds the value 5. First iteration C is equal to 0 plus 4. Yeah, so what's the fix here? Using the L less than equal to, still L is equal to 3, and R is equal to 4. The condition is no longer true. So the loop exists before we check. Not getting second equation. Now L is equal to 3, R is equal to 4. Since nums of C is less than 5, L is equal to C plus 1. First iteration. Initially L is equal to 0, R equal to 4, correct. Second iteration L is equal to 3, R equal to 4. How? L is equal to 4, R is equal to what I say, as long as L and R are not less than or equal to. Still, I am currently trying to mock this up, but I'm not getting it. But probably it's a bad day for me. But hopefully you would be getting it. Let's see. I think I have to rush for another thing. But anyway, thank you for your time. And I think it's a small increment in the our overall goal, but all in all, it's a good effort. In the effort is in positive direction. It's just a bad. Okay, thank you.